Ooh. That's not very happy. That's pooped. We gotta turn that down before the copyright mafia comes and bombs my house. It's fixed. Pretty good. One open resistor and one bad op amp, a 5532. Now it's just to resolder the problem areas, blow out all the dust and slap it on the rear end and put it back in the movie theater. All right, channel 2. Apparently she didn't get to sleep at all. This one's back. This one's been out of commission since apparently 11 of 2008. Here's another one. I believe it is marked as blown fuse on channel 2 down same time, 11 of 08. I can tell someone's been in here because that's definitely not the original fuse. I don't even know if it's the correct value or not. I don't know who's been messing with these, but it's been 20 years. Of course, don't worry, it's unplugged. But I'm just curious what the value of this fuse actually is. So this is an 8 amp fuse that they put in there. The original is supposed to be a 12. This is the original one. This is a ceramic fuse. This is your standard glass one. What almost always happens with these amps, really what kills them, is cold solder joints on the output transistors. And you can actually see, if I can zoom up, you can see how cracked these are. I might even be able to move those. Yeah, I can move that. What happens is when these crack and they're allowed to run that way, it makes and it breaks, and it'll cause these output transistors to short. And I guarantee you that's what's happened. So I gotta suck all the solder off of this with the desoldering tool and find the shorted ones and replace them with something hopefully gain matched enough to match the rest of the good ones if they're usable. Sometimes with these amps also, these 47k ohm resistors down in here, there's a pair here, you see them covered in dust right in the middle of your screen. Those are bridged across the high voltage rails, and what that does is that gives the low voltage section, like these op amps here that drive these pre-drivers here, it gives them their plus and minus 15 volts. And what happens, there's another pair there, is they drift or they go open, and that can cause distortion, or it can also cause the thing to not work at all. But what almost always ends up happening is one of these will go open, or the values will drift wildly apart, and you'll end up with actual DC offset on the output terminals in the order of maybe 1 to 2 volts. I've seen them as bad as 6 volts on the output, and it still functioned. If you have one of these USA 900 or Model 1400 amps, those resistors typically will drift, or one of them will go open. Check this out, the high speed and low speed fan relay here. Look at how cracked that is. There's a big power resistor right here that actually limits the voltage to the fan, so it runs at a slower speed to kind of save on noise. And it, I guess, saves on wear and tear on the fan, hopefully. That is a resistor that's in place normally. And what happens if this amp gets hot enough, there's a thermal switch that'll close, and it shorts across that and becomes high speed. It's actually very unusual to hear these running their fans at high speed. If that's the case, they're being driven way too hard or something's wrong. Also on your driver transistors, you can see that's a problem area. That's gotten quite hot. That transistor is probably bad, but these can crack. Crack solder joints, it will cause it to die. Okay, I know this looks the same from the previous clip. Nothing has changed, except they've removed the solder on all of these output transistors, and I found 2 of them that were shorted. A 21194 and a 21193, both dead shorted all the way across. And probably dead emitter resistors too, I need to check that. The pre-drivers are fine. They're okay, they actually survived miraculously. So yeah, I have a 21194 and a 21193 that are dead. And it just so happens that I have a lot of parts for these amps right here. I need to check and make sure they're somewhat gain matched, but it's not a huge deal. Now I'm going to look for any of these expired emitter resistors, because usually when those go, these go too. I've got the multimeter in diode check mode, and I'm checking across these. I'm doing it with clip leads just for the video here. You can see I got the green and white, or green and yellow clip leads just clipped, and I'm seeing a junction there. Now we're going to move from the, here, let me do this. It's hard to do this with one hand. There's another junction. So that transistor is, for all intents and purposes, okay. Now we're going to take a look at this one, which I've marked with an X, because it's not okay. You don't want to hear this. That is an absolute total dead short. And if you go to the actual case, total complete dead short both directions. This thing is garbage. I checked all the emitter resistors. You're going to see a low value when you look across those with a multimeter. So let me see if I can do this. Yep, that one's fine. So you could just go across these and you're going to look for pretty much the same value. It can vary a little. You don't want it to vary too much. But if these go open, you'll see readings in the thousands of ohms rather than just a tiny percentage here of an ohm. So we're just looking across these real quick. And on these amplifiers, the next bank of them shifts over slightly. There we go. I'm actually really surprised that the emitter resistors all appear to be here and accounted for. Earlier I had mentioned that this transistor was bad. I did actually pull it out of circuit completely. I just didn't have it completely desoldered. I pulled it out, tests fine. So, oops. So we only have one transistor that actually failed. I'm gonna go ahead and get that in there. I did test the pre-drivers, they test fine as well. We're gonna throw it on the dim bulb after a little bit of heatsink compound and see what happens. And a fuse, gotta put a fuse in there too. Okay, I have the problem areas resoldered, including the dropper resistor for the fan, Molex plug, pre-drivers, all the outputs, some of the filter smoothing capacitors. New fuse installed. Fan needs to be oiled. That thing is as tight as it can get. You can see a couple of those transistors have been changed. I checked all of the emitter resistors. They seem to be with us. So let's take it and let's plug it in. There we go. That fan is so unhappy. My goodness. Look at that. There it goes. You can do it, buddy. There you go. Of course, it's on reduced line voltage. No clip light. Let's take a look at our outputs and make sure that we don't have direct current coming out and that this isn't a power supply rather than... There's that fan squeaking. So 0.07 volts, that's acceptable. Half a volt, yeah, okay, yeah. Not great, not that terrible though. So the reason that is there, half a volt of offset, is without reaching in here and lighting myself up like a light bulb. Those two resistors right there in the dead center of the screen, I bet one of those two pairs has drifted, or they both have. Those resistors just love to drift. Also, here's that fan finally taken off. That freaking bearing in that thing is toast. Probably as dry as the desert. Let me go ahead and plug an audio source into both channels and check audio and see what happens. Okay, we've got an audio source and a speaker hooked up. Okay, that one's good. Let's try the next one here. But man, that thing needs cleaned. Yeah. All right, let's plug another one in. Let me 2.1 volts DC on one channel. That's already, I can tell you, that's unhappy. On the other side, half a volt. So that's interesting. No, 2 works. Ooh, crunchy. So usually when you have that DC offset on the channel, it's those two 47K resistors. Usually one of them is way off in value. That can give you that nasty distortion too. So we're going to check those and see what happens. Okay, let's check this first resistor right here. I got one lead clip leaded on the back of the circuit board. And it's supposed to be a 47K ohm resistor that is testing 94K. Explain that one. I'm trying to talk loudly because there's copyrighted music playing in the background. I do work at a radio station. Let's keep it moving. What was that? 177K ohms. Of course that's going to be distorted and awful sounding. How it worked at all? Well, both resistors can drift as long as they drift the same amount. Now, if they differ like that, then you're going to get DC offset on the output. And then this whole front end is going to be very unhappy sounding. Let's test these two and see how they look just to compare, because that other channel worked more or less. This one here is testing at 59K. So that's pretty far off. 59K, 64K. So they were actually close enough that it actually worked. So it's a fair amount of mismatch there that it'll still be acceptable, but this pair down here is totally hosed. So we're going to change those out. And I wonder if this amp would return to normal operation after that. It might. Okay, camera's back up and going. I got those two pairs of resistors replaced. Here's channel 2. That works. Also, our DC offset is gone. We're less than 1/4 volt per channel. Will that stay there? That'll probably stay there. Demonetized. There we go, we're good to go. So, also, here's another really sickly fan. Now, I understand it's on reduced line voltage, but that thing is so dry. Let's see if I can give that a... I'm sure if I give it full line voltage, it'll eventually start moving a little faster than that, but damn, come on now. Little zoom spout oil and those bearings and that thing will be quinko twerculating. So we're good to go. That is 3-4 amps done in one afternoon. I just need to clean them and resolder all the problem areas and put them back. They're dirty. All right, everybody, it's the next morning. I've got all these dusted and cleaned. There's another one on the bench here, and I just cleaned it up. And I'm going through and replacing the two electrolytics that are in the signal path. There's two 4.7 microfarad non-polarized caps. Those are just DC blocking and low frequency blocking caps. I think they protect under about 20 hertz. They cut off. So if you look right here, there's light shining through those vias there where I've removed the solder, and same thing with that one, just as a matter of preventive maintenance. These electrolytics here are for the DC rails. These are the smoothing caps for the plus and minus 15 volts for these op amps. These are the main rail smoothing caps for the high voltage section, and everything else is based off of these, and it's a split rail across the output terminals. Really bizarre. If you can look at the schematic of one of these amps, it's kind of an unconventional design, but these generally never go bad unless there is a really significant failure in the output stage and it shorts, and there's a low impedance load, like less than 2 ohms across these output terminals, then these caps will actually explode. I've seen that a time or two. But I'm replacing these caps, and then I'm going to go through and check all the solder joints, make sure they're happy. I'm going to oil the fan motor, spray the pots, test it, put the covers on it, and label it as a repaired unit. I'm going to do that to all of these. Don't mind my filthy hands. These amps are freaking filthy at one point. Here's one of the new capacitors compared to 2 of the old ones. Okay, so I've hit problem areas with the soldering. I've hit all the problem areas. The Molex connector, driver transistors, output transistors. There was one of these that actually had a ring connection that I didn't see earlier. And the bimetallic strip. Earlier in the video, I called this a relay. It's really not a relay. It's a bimetallic strip, and basically it's 2 pieces of dissimilar metals that bend when it encounters temperature changes, and it's either open circuit or closed circuit, and it changes states based on temperature. While it has a similar action as a relay based on the electrical characteristics of it, whether it makes the connection or breaks it, it's not a relay, that's a bimetallic strip. Here's the resistor that it bypasses in situations where the amplifier needs to cool down and it's running, you know, a little hotter than usual. Here's the two solder connections for the only capacitors in the audio path, at least audibly. And I'm going to flip it upside down and just look at it. I'm going to spray this stereo or bridge switch. I'm also going to spray the pots, oil the fan motor, and I'm going to do that to all of these. So I'm going to go ahead and get all these buttoned up and tested. Here's a much older model 1400. And you see the circuit board is definitely charred right here around where this resistor lives. But something I wanted to point out, and this is an amplifier that actually works. If you look, that solder joint right in the dead center of your screen is definitely cracked. Maybe not completely, but it is pretty much ready to fail. And so it's important to go through and look at all these solder connections and just go ahead and reflow every one of them, whether they need it or not. It's not an option. This Molex connector where your speaker plugs into, also a problem area. So something to be aware of. Also these large dropping resistors, these 47Ks, these get kind of warm over time. If these are on in the order of magnitudes of decades, then these will eventually crack. The circuit board can get a little bit toasty here and here, and especially here. This connector here, this Molex, I've resoldered all of them except for one. And can you tell that one is cracked? Look at that, completely garbage. So I'm gonna go ahead and reheat that and move on to the next thing. These little shaded pole motors, on some of them, they have these little 3 openings on the back, and if you notice, there's a piece of fuzz in there. Well, that's a wick, and that's an oil wick, and it holds oil, and you wanna saturate that with an appropriate amount of oil. Same thing on both sides. I sneak a little tiny bit of oil down on the shaft here and let it soak in, and then I take a paper towel, wipe off the excess. And this also, removing the fan motor, gives you an ability to clean back up in here, and of course clean the dust off the back of the motor and inside, just to prevent any more dust buildup. And that's really all there is to it. Not 100% certain I can fit 4 amplifiers and a subwoofer in this car, so we're going to take a station vehicle. Okay, we are walking down the brown hallway, or up I should say, and we're going to take a look at some amp racks. One of those amplifiers that we previously diagnosed and repaired is in use. This is not the rack with the amplifiers that I fixed. However, we do have a B surround channel that is out in here. So that's my next repair. All right, let's go. That was Auditorium 7. There we go. One of the smaller rooms. One of those is one we fixed. I got a subwoofer to change out in this room. So many amplifiers and so many speakers. Here's another couple of amplifiers we fixed. I'm going without a flash because what I don't want to do is distract people in there. You might be able to see it from the reflection. That's 2 of those QSC 1400s that we've repaired. Yep, putting that repaired 18 into that box. Had to re-glue the spider